All right, welcome to section 4.7. In 4.7, what we're talking about here is inverse trig functions. So recall that what an inverse is a function that sort of undoes another function. So it's the function that's going to get rid of a function. So if we had y equals sine theta, and we were trying to get theta alone, theta would be equal to inverse sine, which is written as sine with that -1 exponent, of y. And sorry, I should change that. This is not the -1 exponent. This is sine inverse. This does not mean sine to the -1st power. That is sometimes a little bit of a confusion, but here what you have is not cosecant. If I had sine to the -1st, that would be cosecant, but this is just our way of denoting that we're talking about inverse sine. As far as the graph is concerned, a function only has an inverse function if it is a one-to-one function, meaning that it has to pass the horizontal line test. So this is throwing like all the way back to, I think, chapter 1, when we talked about inverses. Inverse functions have to be one-to-one, which means they have to pass the horizontal line test. So if we think about the graph of y equals sine x, here's y equals sine x. Looks something like that. There's two full periods of it. It is not one-to-one, because if I draw this horizontal line, it passes this more than one time. So what we have to do is, quote unquote, fix the domain. What we're essentially doing is saying we are going to restrict the domain of the function so that we can talk about an inverse. In the case of sine, we restrict the domain to being negative pi halves to positive pi halves. So graphically, we're talking about restricting the domain from right here to right here. Because within that domain, none of the y values will be repeated. If you were to go to look at your unit circle and think about sine, from negative pi halves to positive pi halves, none of those y values would be repeated. Because if I'm talking about negative pi halves, I'm talking about here. Up to positive pi halves, I'm talking about here. None of these y values will be the same, which is why we can restrict it in this way. We call the fixed domain sine x. Doesn't that seem so different? What you have to note here is the capital S. So sine just written like this, sine, regular sine. Sine written like this means the domain has been restricted to this, even if not stated. So this y equals capital S sine x function has an inverse function because it has been restricted and is one-to-one. Which means, in this case, x equals sine inverse of y, or x equals arcsine of y. So arcsine is just another way of saying sine inverse instead of using that -1 exponent. You have to make sure that you're familiar with seeing either one of these. All right, moving along, the graph of y equals inverse sine x is a reflection of the y equals sine x over the line y equals x. So that might sound a little bit confusing, but if we were to be looking at y equals sine x, so the restricted sign, we're talking about just this piece. Inverse functions are reflections over the line y equals x. So here's my line y equals x. So the inverse function of this is going to be the reflection of this restricted sign over that diagonal line. So if I'm talking about that reflection graphically, it's going to look like this. And in terms of our points, remember that when we're talking about inverses, we're talking about switching x and y. So here, my y values, because this was just regular sine, we're going from -1 to +1, which means now, sorry, wrong way, my x values are going from -1 to +1. So the domain is -1 to +1. The range, a little bit tougher to see in the graph that I had here, but this was 2 pi, this was pi. So this was pi halves and negative pi halves. That was my x values, so in my inverse, those will be my y values. So my range, negative pi halves to positive pi halves. Keep in mind with domain and range, that's telling you essentially what are the things that I could take the inverse sign of. I can only take the inverse sign of a number between -1 or 1, or and 1, including those numbers. And the only thing that I can get as an answer has to be between negative pi halves and positive pi halves. So if you try and take inverse sine of 3, not possible. If you take inverse sine of something and you get 9, doesn't make sense because that's not in this range. So you must have done something wrong. I don't know how you got it. All right, evaluating we're going to talk about in the examples. So now looking at y equals arc cosine x and y equals arc tangent x graphs, it's going to have the same exact idea but different restrictions. The graph of y equals cosine x is going to have its domain restricted to just 0 to pi. So a different restriction, and the reason for that, if you think about what cosine looks like, I'll try and, for some reason I struggle with drawing cosine. Okay, there we go. That's sort of cosine. Let's just move this line over a little bit so it looks more cosine-y. So cosine, fails the horizontal line test. But if we restrict it from here to here, which is 0 to pi, now looking inside that, it passes the horizontal line test. So that's going to give us the y equals cosine x graph with that capital C. If I talk about tangent, so your tangent graph, which as you know, I am miserable at drawing, looks like that, sort of. So this, you can sort of see the natural restriction here. You're essentially just restricting it between these asymptotes, because within an asymptote, or between these asymptotes, it does not repeat. So that will be negative pi halves to positive pi halves. Parentheses around these ones because at those values, you actually are undefined. That gives us the capital T tangent x graph. And then also just to think about the unit circle. When we're talking about tangent, negative pi halves to pi halves, we're talking about here and here. Those tangents will never repeat because tangent is positive here and negative here. If you were talking about your cosines and talking about the unit circle, we're saying 0 to pi, that whole span up there, which makes sense because here cosine is positive, here cosine is negative, so none of those x values will repeat. And they can't repeat, otherwise it doesn't have an inverse. The graph of arc cosine, so we're reflecting this image over the line y equals x. When we reflect that over y equals x, what we are going to get, sorry, I thought there was a graph on this, is going to be something that goes from -1 again to +1. So again, remember my domain, -1 to +1. That's because the range of cosine is -1 to +1. So that becomes the domain of the inverse. The domain of cosine, we were looking from 0 to pi. So that's going to become our range. So I'm going from 0 up to pi. And the way this will work, here at pi halves, we'll have our 0, and then down here, -1, and our arc cosine graph. These graphs aren't going to be super important for our purposes, but these restrictions are going to be extremely important. Those you super have to pay attention to. I'm doing a lot of hand gesturing here that you can't see. Arctangent graph. So I'll change the color to pink because that's what I did arctangent in. So once again, if we're going back to thinking about tangent, the domain of tangent was negative pi halves to pi halves. You know, when we looked right here, this was negative pi halves to pi halves. If that was the domain of tangent, it will be the range of arctangent. So I'm going up to pi halves, down to negative pi halves. The domain of arctangent is going to be whatever the range of tangent was. Well, the range of tangent, it continues infinitely. So that was just all real numbers, or negative infinity to positive infinity. So the way that this graph will look is now instead of vertical asymptotes, I will have horizontal asymptotes because I've switched x and y when I've done an inverse. And I will have that sort of cubic function, but turned on its side. So sort of a tangent function, but turned on its side. Again, the huge takeaway here is going to be this domain and range. The graph is a nice sort of thing to associate it with. Evaluating we'll do in the examples. Please, really, we need to know how to do the evaluating. It's effortless, but super difficult at times. Compositions of functions, I think the last thing that we're going to really be talking about. If we're working between x values of -1 and 1, and we're working with y values between negative pi halves and positive pi halves. So if x is between -1 and 1, then the sine of the arcsine of x is just equal to x. These are inverse functions, so they cancel. But this right here is essentially saying that x has to be within the domain of arcsine. So we said, sorry, I'm going back a lot. Can't find it. We said that the domain of arcsine was -1 to 1. Here's arcsine. So over here, we're saying if I'm going to cancel these, then that x value must be between -1 and 1. Working the other way, if we want arcsine of sine, in order for me to cancel these, this y value must be within the domain of sine. And the domain of sine, when we're talking about inverse trig functions, inverse trig, is negative pi halves to pi halves. As long as it's within there, they cancel. Moving sort of quicker then, if -1 is, or I'm sorry, if x is between -1 and 1, and if y is between 0 and pi, then the same thing will happen with arc cosine and cosine. They will cancel as long as that value is within the domain of the function in front of it. So in this case, I had to be within -1 and 1 because that was the domain of arc cosine. In this case, I need to be between 0 and pi because that is the domain of cosine. As long as they are, they cancel. If x is a real number and y is between pi halves and negative pi halves, not including them, then again, that same thing. It will cancel and it will cancel. Here, it doesn't matter what I take the arctangent of. That's going to exist. Here, I have to take the tangent of something within those restrictions. All right, that's all we're covering in the notes. Go back, listen to something, see if something needs clarification. Some of this composition stuff might need clarification. And then just talking again about these graphs, the graphs of them are not as important to understand what the graph of arc cosine of x is, the understanding needs to be the domain, the range, and what domain and range actually mean. Don't go here and be like, oh, the arc cosine domain is -1 to 1. Cool. What does that mean? Because if you start trying to take the arc cosine of like 7, but you know that the domain is -1 to 1, I'm going to be real mad. All right. So, make sure you've got an understanding of that. Bye.